late 2010 as artificial lift specialist with based knowledge in ESPs as a main operation or as a main function of the artificial lift segment, and other artificial lift methods also. So my humble experience with Schlumberger and with artificial lift started, as I mentioned, late 2010. So I started with Schlumberger Sudan. By then it was the Sudan. So from 2010 to 2012, I was with Schlumberger Sudan. 2012 to 2014, I moved to Schlumberger South Sudan. And from 2014 to 2019, I was in Oman with Schlumberger as well. And from 2019 until the moment, I'm with Schlumberger-UAE, based in Abu Dhabi. So currently, I'm serving as artificial lift job delivery lead for Schlumberger-UAE and based in Abu Dhabi. So this is my humble introduction, and we go to the next slide. So here we have the outline, what we will be sharing with you guys today. The outline goes as we will have a safety moment. Reason being is, we are oil and gas industry is one of the main industries that take safety as the number one priority. So it's good to have a safety moment. And then we will go to what and why the artificial lift method, why we are talking of this subject, or what is it exactly. And then we will move to what are the different types of artificial lift methods. And then we will go to the main artificial lift focus that we will concentrate on today, which is the ESPs, the electrical submersible pumps. And then we will move to ESPs with the bypass system and the Y tool, which is an example of logging while producing. So this is also a special focus. And then we will move to dual ESPs, having dual ESPs. We see why we need dual ESPs and what are its applications. And then we will have, we will try to relate our focus, our special focus points to the South Sudan industry. Most of the audience are based in South Sudan, and I guess the SPE section is for South Sudan. So we will try to link the discussion to our South Sudan industry and to see how the South Sudan industry can benefit from these artificial lift methods in its oil and gas industry. And then lastly, we will have a session of Q&As. So as I go through the slides, please, if you have questions, you can note your questions down, and I will be happy to try to answer them by the end of the session. Yeah, so this is how we will go. So the safe moment is, I just chose a very short topic to talk about. It's the workstation ergonomics. So we know most of us are based in offices, and we tend to work long times, sitting on in front of the computer and in front of the screens. So there's a small slide here. This just to share with us how, first of all, how we need to position the chair and our posture as we sit in the chair for these long hours. We know due to our nature of job, we are always required to stay for a very long time in front of the computers. So it's very important that we correctly position our chair, and the posture, the way we sit, also it makes very important point. So we have, our four arms have to be parallel to the desk. We need to balance our head, thighs parallel to floor. Our back need to be supported, to avoid issues with the back pain due to the long hours of sitting. And then our feet have to be flat, knees clear from chair, so you need to have a clear clearance. As far as the monitor is concerned, we sit for very long times, watching the monitor. So the screen top of level and glare free. So this is just a tip of how you can ensure that you position yourself correctly, or your screen is positioned in a good position where you're sitting. So the easiest way, you can just extend your arm and make sure that at least the screen is like when you extend your hand fully, that's where the screen is, not anything nearby that, so it will not affect your eye. The last point is regarding our hands, how we position our hands. As we will be working these very long hours, we will have mouse, we will have movements, front and back, side, left and right. So this is just showing us how we need to avoid, small side to side movements of the wrist. Instead, we need to use the whole arm to move the mouse, keeping wrist neutral. So this will also help us, not having pains or in the joints of the hands, right? And then the keyboard, this is how you should position the keyboard. Keep your fingers and knuckles relaxed, no excessive force, to avoid stress on the muscles. And then adjust the angle and height of the keyboard. Most of the keyboards, the wireless keyboards, come with angle and height adjusting. So we need to adjust it according to the best position that fits us. Moving to the next slide, we have a question that says, what and why artificial lift methods? I guess when I first introduced this subject, it's a very well-known subject to most of us, and I recognize the presence of, very experienced people in the industry. So just bear with me. Sometimes these informations might be well known to you, but for the benefit of everyone, as introduced by the chairperson, that we have also the student section. So we'll try to simplify it and give the most common definitions of this, and we'll try to ask the most common questions. So just bear with me in case this information, you're familiar with it, but for the sake of the rest, we'll try to simplify things. So the first we'll say, what are artificial lift, or what is artificial lift in terms of terminology? So artificial lift, basically from the name, is a method to lower the bottom hole pressures, or it's a method how we can produce reservoirs to obtain higher productions using artificial lift methods, using something that is not natural, something that is artificial. So in the process of the artificial lift, so another definition goes by, it's a process used on oil wells to increase pressure within reservoirs and encourage oil to surface. So when the natural drive of energy of the reservoir is not strong enough to push the oil to the surface, artificial lift is employed to recover production. So we know most of the fields, like you have a natural flow. Once you complete the well, you drill the well, the pressure at the bottom hole is enough to push the hydrocarbons, the oil, until the surface without the need of any pump or anything artificially that you run into the well. But that's not the case for all the wells, first of all. Secondly, it's not the case always. So, even this naturally flowing well, at a certain point of time in the lifetime of the well, we will need to engage an artificial lift method, because with time, the pressures, the reservoir pressures tend to lower down as the formation is being exhausted. And as a result, the pressures will not be enough to drive the fluid to the surface. So at that point, we will need artificial lift. So this lets us to emphasize that we might either need an artificial lift method right from the beginning, if we obtain from the readings, from the parameters, that the pressures are not enough to come to the surface. Secondly, we might need artificial lift after some time, once we have exhausted the pressure and the well have been flowing naturally for a couple of years or so, and then the pressure depletes, and then we will need to have an artificial lift method. Which artificial lift method is useful, we will find it in the next slide. But for now, this is the introduction, why we need the artificial lift method, or what are the artificial lift method. So the second question is, why artificial lift method? As I spoke in the previous slide, This is the most common question that comes, why we need the artificial lift method. So this is a common phenomena, when the natural drive energy of the reservoir is not strong enough to push the fluid to the surface, one of the artificial lift method is used to recover more production. So in case the pressures are not enough, in case the operating companies are having production targets that they want to achieve that cannot be achieved by the natural flow of the well due to limitation of productions, so an artificial lift method is recommended to be used. So while some wells also contain enough pressure to flow the well or to rise to the surface, which is called the natural flow, which doesn't require any stimulation, most wells doesn't have. So if we take statistics globally, and comparing naturally flowing wells with artificial lift flowing wells, we will find that the number of artificial lift flowing wells are more than the naturally flowing. That's a natural phenomenon. Globally, the pressures will be going down at a certain point of time, and as I mentioned, we will be needing the artificial lift method. So a few statistics on the projection of the artificial lift market. The global artificial lift market is projected to reach 10.3 billion by 2025 for an estimated 8.0 billion in 2020. So if this gives us an indication, it tells us that artificial lift industry or market is a growing market. Reason being is it's a natural phenomena that the naturally flowing wells will, at a certain point of time, the pressures will deplete and we will need an artificial lift method. So it means the number of wells that will be joining the artificial lift methods will be increasing. So that's why the projections shows a steady increase. And just to share something in this regards, the artificial lift market normally, doesn't suffer a lot during the downturns. When we have issues in the prices, issues in the general downturns in the oil and gas industry, the artificial lift market doesn't get affected. The reason being is, artificial lift comes after the well is completed. So the pumps are already installed, everything is in place. So it's not going to cost the operating company anything rather than just optimizing production, which is, increasing the frequencies or the speed that the motors will be running at, hence increasing their production. Unlike other investments that require, operating companies to put in a lot of money to enhance their production. So normally what happens during the downturns is that operating companies will try to limit, any project requiring, new investments, but rather they will just go on increasing their production by optimizing fully the artificial lift method, which is, in terms of cost, will not cost them a lot compared to the other interventions that will be required in case they want to optimize the well. So this just defines or supports these projected figures of the steady growth in the artificial lift market. Continuing to the projection, this is I just put together some of the figures from the global platforms. So here it shows us that the artificial lift industry or market is projected to be 8.0 billion by 2020, and in 5 years' time, it's projected to be 10.3. So this clearly shows us that it's a steady market, it's growing. The demand for artificial lift by every day is increasing. Operating companies are moving to more artificial lift methods to try to obtain their targets, to try to optimize and produce the much or the best that they can from the reservoirs to meet their targets, right? So the global artificial lift market is mainly driven by the growing investments in the upstream oil and gas sectors, increasing production of heavy oil and rising advancement in shale developments. And in North America, artificial lift market is relatively large than the other regions owing the high focus on shale gas, oil extraction, large number of matured oil and gas fields, right? So these are just some supportive information showing us that why the artificial lift industry is growing. The chart below shows the steady growth, you can say, from 2018 until 2025, reaching the projected figures of 10.3. This leads us to a question that says, what are the different types of artificial lift? We have known what an artificial lift is, why we need the artificial lift in the previous slides. So this takes us to the next question that says, what are the different types of artificial lift methods? So artificial lift have a lot of methods. We will try to go through the most common ones until it leads us to our main focus, which will be the ESPs and the other related applications that are linked to the ESPs. That's our main focus of today's presentation. So the first type of artificial lift, we have the sucker rod pumps, or they call it beam pump, or in some other parts they call it donkey pump. I think it's very common. Most of you have seen it, if not all of you. So this is one of the artificial lift methods. So sucker rod or beam pump is the oldest and the most widely used type of artificial lift for most wells. Sucker rod pumps is made up of several components, some of which operate above the ground and other parts which operate underground. So here we have, it's combined. So we have the motor and everything that is on the surface, but however, we have some of the parts that are also linked, that goes into the well to produce the well. So we have components of both on the surface, like here we have the motor that drives the beam, and the beam will give us the rotation, and it will give us the stroke when it goes down. The stroke, when it goes down, it will give us how the mechanism underground of the pump will be opening the chambers to contain the oil, and as the process continues, we will have the flow to the surface. So this is just a brief introduction about the sucker rod. Secondly, we have the progressive cavity pumps, which is the PCPs. It's also a very common artificial lift method. The PCPs is a positive displacement pump, and is considered to be one of the artificial lift methods. It's a screw type pump that provides a force for fluids to travel through the pump. So it's a positive displacement pump, and the type of the pump is a screw type, which provides force for the travel. It goes from one section to the other until it reaches the surface. So PCPs are capable of producing for wells characterized with high viscous fluid and high sun cut. So this gives the PCP an advantage maybe over some of the other artificial lift methods, that it can be used for highly viscous fluids, high sun cut, because of the mechanism of the pump, it can produce heavy fluids with low APIs, and the high sun, because the rotation of the PCP is very low compared to the ESPs that rotates at a very high speed. The RPM for the PCPs are very low, so it will not disturb the reservoir. It will not produce much of a sun. So in case you have a sandy environment, PCP can be a good option to look at. The third point is that it's lower operating and capital costs. It's not costly as the other artificial lift, ESPs or the other one, partly due to their simple design. The design is simple and the installation is simple. Almost everything is on the surface. If anything goes wrong with the motor, you can replace the motor. And unless if there is any downhole issue, then you will need to have an access to the downhole by pulling out the completion, right? So it says here the lower operating and the capital cost, partly due to simple design and installation and lower power consumption compared with other artificial lift methods. making them cost effective and an efficient artificial lift solution. So here, this is a simple sketch for how the PCP is. It consists of, starting from the downhole, we have a starter and a rotor, and then here goes the production tubing, and then we have the rod itself, and then we have a coupling or centralizer that helps, keeps the rod centralized. And then here we have the drive head or the wellhead drive, and then we have the prime mover, which is the motor basically. And here is just an sketch of where the flow line is, or where you will be flowing the well. So this is just a simple sketch to show us how the progressive cavity pump footprint is laid down in terms of downhole and in terms of the surface equipment. The third artificial lift method that we will look at is the gas lift. So gas lift is a method also of an artificial lift, which uses external source of high pressure gas for supplementing formation gases to lift the well fluids. So basically, it's a process of injecting gas into the well to help increase the formation pressure and help flow the well by getting the hydrocarbon to the surface. So the principle of gas lift is that gas is injected into the tubing. So in the tubing, we will have like gas valves or gas mandrels. It's injected into the tubing to reduce the density of the fluid in the tubing, and the bubbles have scrubbing or action on the liquids. Both factors act to lower the flowing bottom hole pressure at the bottom of the tubing and helps us, obtain a flow to the surface of the hydrocarbons by displacing the hydrocarbons. So there are two basic types of gas lift used as today. We have the continuous and the intermittent flow. So there is a continuous gas flow, and then there's intermittent gas flow as a gas lift method. The other artificial lift method is the horizontal pumping system. So HPS is one of the artificial lift methods. And HPS is a horizontal pumping system. It's a multi-stage centrifugal pump mounted horizontally on a skid, as we see in the picture, for surface pumping. So basically, this is an HPS from its name. It's a horizontal pumping system, which is mounted on a skid, metal skid, to give us a flow or used for surface pumping. So horizontal pumping systems are used in variety of applications. We can use it for water disposal. We can dispose water using the HPS. We can use it for water supply, for booster services, okay, for crude oil transfer. Stations, they use this HPS to transfer the oil. For some injections generally, when you can use it for water injection, you can use it for liquid propane injection. And the main parts of the HPS is, the part here where I hover my mouse this is the motor. And then somewhere here we will have the coupling or the thrust bearing and the coupling. And then here is the suction or the intake. Normally you suck in from a tank, you suck in from a surface reservoir to inject it somewhere. So this will be the suction. And then we have a lubricator here that lubricates the bearing, that lubricates the coupling. And then we have the pump itself. So this is the multi-stage pump as mentioned here, the multi-stage centrifugal pump. This is the multi-stage centrifugal pump. And here we will have our discharge. So whatever will be taken in through the intake or through the suction will be displaced through the discharge to the flow line or to the injection wells, depending on the applications as mentioned here. The next type of artificial lift method is the electrical submersible pump, which is our main focus of today's slide or today's presentation. And I will not talk about it now because there will be several slides that will follow that will focus on this. And I will just mention other non-common type of artificial lift, just for the record. You know, the reciprocating or the jet hydraulic pumping system. This is also one of the artificial lift methods. It's non-common. And also we have the plunger, the plunger lift or the plunger pumps. So this is also one of the artificial lift methods, but it's not common in the industry as of today. But the previous ones that I've mentioned, they are quite common and applicable in the industry, in the industry as we talk of today. This leads us to the next slide of one of our main components of today's presentation, which is the electrical submersible pump. So electrical submersible pump, typically called an ESP in the industry, mainly people just call it by the acronym, is an efficient and reliable artificial lift method for lifting moderate to high volumes of fluids. So it tells us that it can handle high flow rates. These volumes can range from as low as 50 barrels per day to as much as 150,000 barrels per day. This depends on the pump, depends on the specification of the reservoir, on the heads that you will install, the pump heads that is required. So basically on the pump type. So whenever you need more production, considering other considerations that might be applicable. So, but you have the option of producing as low as 150 barrel per day from an ESP system to as much as 150,000 barrel per day from an ESP system, depending on the applications, right? And how good the reservoir can support. It's deployed in an estimated 200 plus wells worldwide. So this tells you that it's one of the most commonly used artificial lift methods globally. So the electrical submersible pump, uses the variable speed drive. So this is a surface system. It's a surface system. Basically, it's an electric drive. It gives the option to the downhole ESP of running the ESP at different frequencies, hence obtaining different flow rates depending on the operator. So at a certain time, the operator would like to optimize the production until the maximum. At a certain point of time, it gives them also the flexibility, of playing with the speed in relative to the production, due to sun production, due to any other reason that might be there. So the VSD or the variable speed drive gives operators this option of playing with the production rate from an ESP system. So this tells you that it's not fixed. You can produce, every pump have different ranges. So whenever you buy the pumps, they tell you that this is the range of the pump. It produces between this and this. This is as the minimum. This one as the maximum. So it at any time of the running life of the well, the ESP can be optimized or can be used through the VSD to play with the speed and hence give you the production that is expected. So you have the flexibility here of playing with the speed of the ESP through the variable speed drive. The main components of an ESP system, as in this picture here, first of all, ESP system, if I go from the bottom, ESP system will have a sensor, for data acquisition. It's very important. Customer would like to know how what are the readings of the downhole in terms of pressures, in terms of temperature. So this will help them, analyze this data and hence know the best condition that the ESP can run under to help them plan for other wells or for this current well itself. It's an option. You can run a sensor in the data acquisition system, a sensor with the ESP, or you can run it without an ESP. So this is an optional part. We go to the motor. It's a mandatory part. We need to have the motor. The main reason of the motor is the one that gives us the the rotation, right? So you give power through the power cable. It goes to the motor. It obtains rotation. The motor rotates. There is a coupling, and then it gives the rotation to the top part. As I go, I will explain. So here we have the motor. On top of the motor, we have protectors, or they call it seal. Some companies, they call it seal. Some people call it protectors. Basically, these are, housing with chambers of filled with oil. It's the main option. Its main objective is to prevent, water from going into the motor. When water goes into the motor will fail. It will burn. So the protectors uses the mechanism of, difference in fluid density. It is filled. The chambers in the protectors are filled with oil. So whenever we have, the intake, which is right above the protector, the oil will go from the intake. Some of this oil will go into the protector, and this oil that is coming from the reservoir have solids, have water, some water content. So to avoid this from reaching the motor and hence failing the motor, we will install these seals or these protectors. Because of the oil that we have in the protectors, it will try to keep the water on the top due to their differences in density. So it will avoid water coming into contact with the motor, and hence it will give you a longer run life. So this is the intake. On top of the intake, we might have a gas separator. It's an option. Whether if the reservoir is gassy, there's a lot of gas that need to be handled. Otherwise, if we don't have a gas separator, you can have a pump, which is a mandatory part of the component. And then on top of that, you will have like your discharge sub, and then you have your production tubing. There are a lot of other options that you can put here. If there is an application for a packer, it comes on top of the ESP. If there is other applications, some safety valves as for well control or well integrity purposes, they all come on top of the ESP. So basically, this is how the ESP looks. We have a power cable that will be running from the surface. This is the VSD, which we talked about, or a surface control equipment. It will have components like, the drive itself. And then you have a step-up transformer. The voltage will go from the step-up transformer to the motor. Once the voltage goes to the motor will rotate. Once the motor rotates, it's connected through a shaft with the protectors, and the protectors are connected with the shaft with the intake. Intake is connected with the shaft with the gas separator or the pump. So whenever the motor rotates, you will obtain rotation for the whole system. And this rotation that is driven by the motor will give the pump, rotation, which gives the pump the capability to produce, because we will start having, rotation from the stages, because the pumps consist of stages. So it will have the rotation of the stages, and hence we will have oil going from one stage at the bottom until it reaches the surface, where it will be pumped into the production tubing until all the way to the surface. So this is a simple sketch of what an ESP is. The next slide is, we talked about ESPs, and here we are going to talk about application of ESP with bypass and Y-tool system. So this is, it's a separate component, but they are run together with an ESP system to give us some other advantages and benefits that we will look into. So we have the ESP with the bypass and Y-tool system. First of all, Y-tool, it comes from the name. If we look at this picture here, it's like an inverted Y. So it's like an inverted Y. So this is why we have the name Y-tool. And the bypass, basically, it's this tubing that is along the ESP. They are called the bypass tubing. So why we need this one, or why this system, we will go into it in details. So we have the Y-tool in the bypass system. It's a solution to enable intervention or logging with wear line, E-line, coil tubing below the ESP at any point of time during the production without the need to retrieve or pull the completion. So what does this one mean? It means that this Y tool system with the bypass, it gives us, or it gives the operators an option of running a wear line, running an E line, running a coil tubing, or any intervention tool below the ESP for data acquisition, for some studies, without the need to pull out the ESP that is already installed in the well. So one of the main advantages of the Y tool system is that at any point of time, the operator would like to run a well line to do some, to get some data, to run a coil tubing to do some stimulation. You can easily run the intervention. You run it, your ESP will be here. So this is how the structure of the Y tool is. Here you have the production tubing. It will be only one tubing that goes into the surface. Here you have the Y tool system that looks like an inverted Y, as I explained. So on this side here, on this side here, that is next to the bypass tubing, you have the ESP. So the ESP system is installed here on this side here, which is offset to the production tubing. If you see, the production tubing is here, and this is an offset. It's not straight to the production tubing. However, the side that is straight to the production tubing, that is concentric to the production tubing, is where the bypass is. So you have the Y tool as a component. Then you have the ESP system with its different parts, as I explained in the previous slide. You have pumps, intake, protector, you have motor or sensor. So this is an assembled string. Beside it, you will have the bypass tubings that is run by the side of the ESP. And at the bottom here, this is an optional, they call it pump support block. Basically, the pump support blocks, the function of the pump support blocks, it takes the weight that is below it. Some applications, the operator will say, I would like to run like 300 joints or 200 joints below the ESP. They call it tailpipe. So if the customer says, I would like to run 300 or 200 tailpipes below the ESP, those tailpipes will have weight. And if I do not install the pump support block, all the weight will be on my ESP system. So this tensile strength of the ESP system is not designed to withstand the whole weight of the application below. Therefore, ESP providers, they came up with this pump support block, which basically will hold all the weight that is below the ESP, all the weight of the tailpipe, and then only the Y tool will take the weight of the ESP and the Y tool system and the bypass system. So any weight that is below will be handled by the pump support block. For applications where you don't have a very long tailpipe, you will not run the pump support block, or there will be no need to run the pump support block. So basically, it says here the Y tool is installed on the production tubing, providing two separate conduits. So one conduit is this one, the bypass side, which is concentric to the production tubing. And the other conduit, which is offset to the production tubing, is where the ESP is with production tubing, and enables access to the reservoir below the ESP. While the second conduit, which is the offset, as I explained, and is the ESP side. So looking into what is here, basically this is the Y tool. If in a more close look, this is where the ESP will be, the side that is offset, and the other side, which will have the bypass. Continuing on the ESP with bypass and Y tool systems. So this ESPs system, it gives the operator an option of logging while producing, or running any stimulation tool, or doing any stimulation operation while the ESP is into the well. We know there is, pulling out an ESP, it comes with its cost, right? So instead of pulling out the ESP just to run the coil tubing or to run the wear line, having a Y tool system with the bypass will allow you as an operator, will allow the operators from having the option of running the tool while the ESP is installed in the well. So here it says the Y tool and the bypass system also provides a method to configure more than one ESP in a well. So that's another use of Y tool. You can use it for dual string. You can use it for dual string. So that's another use for a Y tool system. So with an ESP with a Y tool system, operators can carry out wireline, coil tubing logging, memory gate deployment, tubing conveyed perforation, well treatment, stimulation operations, effective managing production operations and reservoir performance without the need to pull the ESP. So all these mentioned operations can be done without the need to pull out the ESP that is already in the well. So it's just a matter of shutting down the ESP for a while. Wireline will come, rig up their wireline unit, they will run, coil tubing will come, they will run, finish the operation, pull out, gives the data to the operator, ESP company will restart the ESP and production is resumed without the need to pull out and without extra cost for rig mobilization or so. Also, it gives the dual ESP installation option. You have a dual ESP. I will talk about the dual ESP in the next slide. Also, it gives the option of a bridge plug setting for water shutoffs. In case you have water shutoffs, it gives you the option to run a bridge plug through the bypass system or through the Y tool. The next point is, when we have a wireline or coil tubing plugs. So when we run this operation, we always have plugs to be run. The coil tubing guys, if there are people here from coil tubing, from wireline background, they have we have common plugs that we run. So these plugs are identified according to the profile. This is how the Y tool looks like. Here we have the ESP side, the side that is offset to the production tubing. And the side that is concentric to the production tubing, we have a nipple profile here. So the Y tool here comes with a specific profile. This profile is matching with the size of the plug. So you will tell the wireline company, the coil tubing company that, okay, this is the profile of the Y tool, and they will get a specific tool that is matching to the profile that they can run through, and it will not have any obstruction here. This gives us that an ESP can run these plugs in place to perform production logging and other well interventions. Continuing to the same topic, there are two types of bypass or Y tool system. We have a standard Y tool system. A standard Y tool system, it comes that the profile here will have a plug that you need to run the plug into it to close it, because once you're producing, as I've explained earlier, the ESPs will be on the side that is offset to the production tubing, which is here where I hover the mouse. So when you are producing from the ESP and there is no any plug here, there will be a circulation. So you will not obtain the pressure at the surface. The reason being is because here will be hollow, will be no obstruction. So whatever you're producing from here will be circulated back into the well. And then you will end up not having any flow in the surface. The ESP will be running, but you will not be obtaining any wellhead pressures. So in the standard type of Y tool, it has to be run with a plug. So once you assemble the ESP with the bypass system, you run it all the way to the setting depth. You land it. So wireline or coil tubing or slick line will come. They will run this plug. Run this plug before you start the ESP. They will set this plug here. They will do pressure test. Okay, ensure that this plug is totally sealing this area, so that when you start the ESP, you don't have a circulation. In so many instances, you will even have the plug in place, then sometimes you don't have pressure in the surface, and then when they pull out the plug, they will find that the plug was leaking for any reason. So for a standard Y tool type, it is a must to have the plug run in place before you start the ESP. Otherwise, you're going to have circulation once you start the ESP, and you will not be able to obtain the fluid in the surface. The second type is the auto Y tool. I will talk about it in a separate slide. So standard Y tool or bypass system is supplied as part of an assembled pressure tested subassembly ready for use in the field. So it will be supplied with this plug installed in it, pressure tested. However, some applications or some operators require that while you're running the ESP, you have to remove the plug. So you can remove the plug, but by the time you land, you set the pump at its required pump setting depth according to the tally. Coil tubing, slick line will come. They will run the plug, pressure test it, and then and only the ESP can be started. So the standard Y2 requires a blanking plug. It's called a blanking plug to be set into the telescopic swivel nipple. As I explained, there is a nipple profile here that matches the size of the plug that needs to be run to prevent recirculation of the production fluid, as I explained. Where intervention work is required in a bypass system with a standard Y tool, blanking plug is a must. It has to be retrieved. So as I explained, they run it here to secure so that whenever I start the ESP, I will not have circulation. So after some time, they want to have an intervention with a wear line, with a coil tubing, with a slick line. They will come again, rig up their tool, run. They will pull out this plug. They will pull out this plug. It's a very common industry application. They can jar it up, they pull it to the surface, and then they can run their tool, do their logging, do their perforation, do their stimulation. Once the stimulation is done, they pull out their tool and run another plug in the same place to secure, and the ESP can be started. So Y tools generally are available to suit a wide range of casing sizes, starting from 7-inch, 7/5/8, 9/5/8, 10 quarter. So Y tools are available in the market. It gives the operators a chance to run it at different casing sizes, which is a positive thing to the operators. It will not limit them. So they will just need to see which type of which size of Y tool is suitable for their casing application. The second type of Y tool or bypass system, as I explained, is called the auto Y tool. So auto Y tool is supplied as part of an assembled pressure tested subassembly ready to use in the field as well. The auto Y tool has an internal diverter. So this is how the auto works. Remember, in the previous one, we don't have, this place is hollow. But for the auto Y tool, we have a flapper. So this is the flapper now, it's right vertical. That's why it's very difficult to see it. In the second picture, the flapper closes on the bypass side, allowing the ESP to produce. So the flapper works is, if the ESP is running, there will be a pressure coming from the side that is offset. It will push the flapper upward, and then the flapper will rest, closing this bypass side, and the ESP will produce. The moment the ESP stops, pressure here will go down, and the flapper will go back to seal the ESP side. Any activity for wear line, for coil tubing, can only then come and run in the place. So this auto Y tool, it doesn't require a plug. It have a diverter valve that is already installed. Whenever the ESP is running, it will push it with pressure and seal the other side for the bypass tubing, allowing the ESP to flow. And once the ESP is stopped, automatically the flapper will go back to close the ESP side, allowing any access for the coil tubing or stick line operation to be run without the need of the plug to be retrieved. So it says here the auto Y tool has an internal diverter which seals the bypass tubing when the ESP is operating, preventing circulation, and automatically closes over the ESP discharge lock when the ESP is shut down, allowing intervention access through bypass tubing. So the function replaces actually the blanking plug. We don't have a blanking plug in this application because we already have the diverter valve that works automatically, and I can access without. So in this case, when an intervention work is required in the bypass system with a standard Y tool, the blanking plug must be retrieved. However, in a bypass system with the auto Y tool, it is not necessary. So this tells you, advantage of the one over the other. But it then depends on the application. It depends on the customer, which one they will go for it. But it gives you an option. It takes us to the last special focus subject that we put for today, which is the dual ESP. So we had known the artificial lift, we known the ESP, we known ESP with bypass system. What are the different types of bypass systems? This leads us to come to the point of a dual ESP. So it's a common industry terminology. People talk of dual ESP, dual ESP. Basically, dual ESP, is an ESP system that enables cost-effective production in applications where rig availability may be at a very expensive cost. So, mainly for offshore operations where rig costs are very expensive, customers tend to look into the option of running dual ESPs, two ESPs in the same well, so that whenever one ESP fails, they will not need to mobilize a rig, which will be very expensive. However, they will just switch to the other ESP and then flow the well for a while. So if any well gives you an average run life of 3 years each, so you will have a total run life of 6 years, which is pretty good for the operators to get their revenues, or to get the money they spend on the rig. So this is one of the uses of dual ESP. And then another point is that dual ESP production systems are capable of pumping reservoir fluid from two separate zones, simultaneously in the same well bore. So you can produce from two different zones because you install them at different zones, and then you will be able to produce simultaneously from these two zones. So this enables the operator to isolate and measure production from two separate zones, in these multi-zonal completions. So it gives you the flexibility. It gives you the option to test each zone separately, compare the parameters with each other, compare the readings, and it gives you an in-depth knowledge, to know how these two reservoirs are behaving. So this is one advantage of the dual ESP system. A modified version of a dual ESP system that uses the same concept can be used to inject fluid into one zone and produce from another in the same well. So this concept in the industry is well known to be called as dump flood. So dump flood, this enables the operator. You can produce. For example, you have a well. You're producing. Mainly, they use the dump flood for water wells. So you're producing water from here, from this reservoir here, and then when it comes, you produce it through the tubing. It comes to the upper ESP, or to the upper Y tool system. It will have a block that will be, once the production is going up, it will have a block somewhere here, and then again it will be re-injected to a reservoir that is on top, or that is in a different zone from where the bottom ESP is. So this is the concept of the dump flood. You produce from the reservoir that is at the bottom. However, when you reach the reservoir that's at the top, you will have a plug. The production will not come all the surface to the wellhead. It will be plugged somewhere, and then it will be re-injected through the Y tool system, into a zone that is above the zone that it was produced from the beginning at the bottom. So this is using the same concept of the dual ESP. Last point is that the dual ESP system can also function as an in-well backup system, as I explained earlier, to give you, as a backup system. There are wells with high potential, so you cannot afford to bring rigs which are very costly. So you run two ESPs. One ESP fails, you have the option to switch to the other one, and you continue production, which reduces, downtime, and lost or deferred production while mobilizing rigs, and so. My last slide goes by, as I explained earlier, all what we had been talking about from the beginning. We have to kind of relate it to our South Sudan industry and see, what are the takeaways that South Sudan industry can benefit from this simple technology that I have explained today. So this goes by the benefits of ESP with Y tool and bypass system, and the dual ESPs to the South Sudan market, right? So we start with the bypass and the Y tool system. It allows operating companies to perform the below activities. You can run a wear line or coil tubing without the need to retrieve the already installed ESP, the memory deployment gauge. You can do perforation at the lower zone without need to retrieve the ESP. You can do well treatment, stimulations, which can optimize your production, which can help the well perform better, enhance your production. You can effectively, manage production operations, reservoir performance without the need to, all this without the need to pull the ESP system. And then the dual ESP, the benefits that we have to look into when we look into our South Sudan industry, or what it can give. It can enable operators, to isolate and measure production of two separate zones in these multi-zonal completions. So it gives you an option. You can understand the in-depth information of these two reservoirs, how they behave, and then even when the ESP is running or when the ESP is not running, because you will have the sensors, as I explained, that will give you the data, real-time data that will help the production engineers, reservoir engineers to decide what is the best approach for the reservoir. Cost-effective means for expensive freak interventions as backup ESP systems. Dual ESP production systems are capable of pumping reservoir fluid from two separate zones simultaneously. That's an option also. And then operators can use the dual ESP concept to produce from one zone, lower zone, and inject it in another zone, which is in the upper zone, in the same drilled well, which is the dump flat project, without the need of drilling another well. So this, sorry, I just slide in a little bit, maybe 7 minutes into the top of the hour, but this brings me to the end of the presentation. And I will be ready now to hear your questions. I don't know, Edwin, maybe you can
Yes.
you can take it from here by starting giving, if there are questions, I will be more than happy to take them.
All right.
Thank you so much.
All right. Thank you so much, Engineer Alan. We have a couple of questions on the chat box. We'll focus on it first, then we'll give a chance to others to unmute themselves and ask questions.
Sure.
So yeah, there are a couple of questions here. However, like two of them were answered by Nelson. I think he already answered it. I will take the questions that have not yet been answered. One of it is from Robert Atomic, who is a production technologist in Depok. So he was asking about why installing the tailpipe below ESPs.
Okay. Yeah. So the reason of the tailpipe, basically, operators sometimes they would like to have intervention at depth that is very low, that is very low or very deep from the ESP setting depth. For example, you will have a well, the TD. TD is 6,000 feet. Your pump is set at 3,000 feet. However, the operator would like later on, at the course of the run life of the ESP, to have an intervention at 5,800 feet. So if you look at 3,000 where for example, 3,000 where your pump is set, to where you are planning to run your intervention later on, which is 5,800, this is, you will need a lot of tubing to be run below the ESP until it reaches from 3,000 where the bottom of the ESP will be until 5,800. So this long tail pipe is basically depending on the operator where they want to have the intervention. But as I said, and I related it to the pump support block, the pump support block is optional. When you don't have a long tail pipe, there is no need for for pump support, because there will be no any weight below the ESP. It will be only a couple of feet below the ESP, and it is fine. It can be handled by the Y tool. However, if at the design phase of the well, the production engineers decided that later on we want to have an intervention at a very deep depth from where the ESP is sitting, which takes 100, 150, 200 tubing, we will need to run coil. We will need to run a pump support. So again, to his question, while we need the tailpipe, it depends on where you want to have an intervention later on to allow you to do it. Yeah. So I hope I'm able to answer, and that's what he means.
Another question here is on, in case of walkover jobs that involve water shut-off and add perf, is it applicable with the Y tool?
Hello?
This is from Garang.
Yeah,
Hello?
come again. Because there was an intervention. Someone I think is trying to say something. I don't know.
Yes. Let's just finish. I just try to mute most of the people.
So okay. Yeah, the question again, sorry.
Yeah, the question is, in case of walkover jobs that involves water shut-off and add perforation, is it applicable with Y tool? Is the Y tool will be helping on this? Like in case there is a Y tool installed in the well and there is a job for walkover of like water shut-off plus add perf, will it be possible to be implemented?
Yes. To answer that question, it's a very good question. To answer that question, yes, it is applicable, and this is actually one of the main reasons you have a Y tool in place, because it will allow you an access to have access to do the walkover, to have the stimulation process, to have perforation even. You can run all these perforation guns, these stimulations, coil tubing, especially the stimulation, they do it with coil tubing. It can pass through the profile that I explained in the Y tool system. It will go below the ESP, so you will not need to worry that your ESP will be damaged. You will go do your walkover, do the perforation, pull out the system. If it is a standard Y tool, you run the plug in place. You can restart the ESP. If it is auto, you don't need to run any plug. So yes, answering his question, yes, we can do intervention for water shutoffs. We can do intervention for perforation while the Y tool is there. Yeah.
All right. Another question from Obach. What is gas minimum quantity that require gas separator, and what additional surface equipment that it will require?
So let me take it to have the exact figure. I might need maybe to dig out and see the exact quantity, because normally this design is you run it on an application, and the application will trigger. There are some alarms that trigger whenever your gas ratio is high, which allows you to use, because in the gas separation we have like advanced gas handlers and we have gas separators. So each of these systems in the ESP companies that provide it, they have different ratio of gas separation. So in terms, there is a ranges. So in terms, the range is high, you go for advanced gas handler that can handle bigger ratios of gas, and you can go for gas separators that can handle less ratios of gas. But to be a specific of the values, I might need maybe to see some of the figures of these gas separators, their series, their specifications, to be exact. And this might differ from one operator to the other, right? From one service provider to the other. But there are certain ranges, yeah. And the second part of the question is what?
Is
it was a two-phase question.
Surface equipment that is needed in this case. Surface equipment.
Yeah. So if you have a gas you have a gassy well, and you install these gas separators or advanced gas handlers, you will not need to have any. It's an option anyway, but it is not mandatory to have a surface facility to again handle the gas. So yes, some of the clients, they are worried about having gas at their process facilities, so they might install some gas separators at the surface. But as far as an ESP person is concerned, once I separated the gas at the bottom, because once I separated the gas, and as I explained in the sketch, the gas separator comes before the pump. So the reason I'm separating actually as an ESP company or as an ESP provider, I'm separating the gas, is that I don't want the gas to go into the pump to create a mechanism that is called gas lock. And whenever a gas lock happens, the ESP will be running, but no flow to the surface due to the gas lock mechanism. So me as an ESP company, my worry is to separate the gas from the oil before the oil reaches the pump, so that I will be able to flow the well, I will be able to flow the oil until the surface. Whenever it reaches the surface, yes, some other facilities can be installed, which is not mandatory, which is not linked to the ESP system, but however to the process. Before reaching the process facility, the client would like to have, separation of all the gas, not to cause some complications or implications at the process facility. But it is not related to the ESP. The main reason me as an ESP company separating the gas at the bottom is that if the gas goes into my pump, it will create a mechanism called gas lock, which will make the ESP not be able to produce due to this gassy situation.
All right, that's great, Alan. So we have 4 more questions before we open the floor for the audience to unmute themselves. So there is a question from Benedict. Why is it that artificial lift technologies cost will increase to over 10 billions by 2025? Is it due to more new frontiers or oil fields are going to be developed, or is due to all oil fields are increasing?
So I think, yeah. So just to mention, the figures I've mentioned, it is not actually the cost of the artificial lift, but it is the projection of the market of artificial lift. In other words, it means that the artificial lift will get more business in these projected years. Reason being is it's a natural phenomena. All the naturally flowing wells at a certain point of time, the pressure will deplete and you will need an artificial lift method. This is one reason. Second reason is operating companies normally, they have production targets. They have certain period of investment that they are investing in the country. So they would like to obtain their objectives, their revenues, their projected revenues by increasing the production. So when I have a naturally flowing well that gives me 3,000 barrel a day, and I would like to have a 5,000 barrel production, regardless it is producing naturally, I will say, okay, I need to run an ESP. I will need to run any artificial lift method to give me that 2,000 barrel extra so that I can obtain my objective as a company, right? So this goes into this detail. It's not the cost that artificial lift is going to cost that much, but however, it was the projection of the market, meaning that it is a growing market due to the reasons I've mentioned. Showing anyone who is worth investing in the artificial lift industry that it is projected to be a profitable market because the demand for it is increasing due to the reasons I've mentioned.
Okay. All right. So there is another question here asking for the dam flood application of the dual ESP. They say that once production reaches the upper completion, where you say water can be reinjected into the zones above bottom, do we have any separator there, or how do you segregate waters and oil prior to reinjection?
Okay, so the dam flood project, mainly it is for water injection. So meaning you are producing from a water well at a bottom formation, say it is at 5,000 feet. You are producing the water, fresh water well from 5,000 feet, and you would like to inject it somewhere around 2,000 feet. So instead of drilling a water source well and then drilling an injection well at 2,000 feet, you will drill one well. In this one well, you will run an ESP at 5,000 feet, which will produce for you the fresh water from the water source well. And then above, say 1,500, you will run a plug just above the Y tool. Below the Y tool, you will run a one-way valve that allows the water that you produce from the reservoir, whenever it reaches the top Y tool, where you will have a plug, from not going again into the same formation where it was produced, but rather it will go into the other side, allowing it to be injected at that zone, which we say, for example, 2,000 feet. So it eliminates, the need of drilling a complete one well just for injection, but it is not like you are producing from an oil well and then you separate the water and then the water you inject it there. No, it is like you have a water source well, you produce the water from the water source well. However, instead of having a separate injection well, you inject the water, the same water you produce at a certain depth that is above the 5,000, for example. using the plug that is run above the Y tool, and below the Y tool you will have a one-way valve that will only allow oil, water, the produced water, to go from the bottom where the ESP is run. So it is not a situation whereby we have an oil with water well that gets separated. No, it's like a water source well and a water injection well in one well. So it gives you an option of eliminating a complete cost of one new injection well.
All right. I think that was like a comprehensive answer. If I take it from a reservoir engineering perspective, yeah, we have not implemented yet the selective injection in South Sudan. So this is part of the water flood optimization. Like within the same injector, you can like using the dual ESP, you can direct where you want to inject, right? Because between the two dual ESPs, you have packer. So instead of like you have like a lower pressure in the shallower reservoir, you can recirculate the water using this dam flood application. Thank you for this, Alan.
Yeah.
Yeah, if we go to the other questions, there is a question from Adam saying, cost-wise, how effective is to utilize the Y tool in our oil fields?
Yeah, see, and Y tool is not a very expensive component because, as I've explained, it's a very basic. It's a housing. It's a tubing, just shaped in a Y shape. Internally, it has some profile that requires some plugs with a certain configuration. But generally, I don't know the cost, and here we are not for a marketing purpose, right? But it's not a very expensive technology. Yes, it comes at its cost, but it is not a very expensive technology to invest in. Looking into the cost of a walkover, that I need to pull out the whole ESP with the tubing, the cost of the ESP company, the cost of the drilling rig or the walkover rig, plus other interventions in between, just to run later on the wear line. That if I run a Y tool, whatever cost it will have, for sure it will not be the same cost of a rig or the interventions that I've mentioned. You will only pay for the cost of the Y tool, and then whenever you want to do stimulation, coil tubing, wear line, everything, it is a rigless operation. Coil tubing will come, rig up their tool, run, remove the plug, do the stimulation, do the perforation, pull out, run a plug to close the plug, the profile, and you run your ESP. So, Adam, to answer your question, it is not a very expensive investment. It's worth it because comparing your cover cost, comparing pull out cost, it is very high. And in most of the cases, the ESP is even healthy. So there is no need for you to pull the ESP. It's just you stop the ESP and then you do it. So whenever you don't have most operators, they don't have option rather than to just wait until when the ESP fails. Then that time they will say, okay, before now, when we are pulling the ESP, before we run the new ESP, then you should mobilize Wireline to come and do for me the logging. But when you have the ESP at any Y tool, at any point you have, the reservoir pressure is going drastically down, you can stop the ESP, run a logging. Wireline will give you a better idea what is happening in the reservoir, what changes happen, and you can take this recommendation from the production engineers and run your ESP accordingly, and hence give it a longer run life. So to summarize the answer, it's not a very expensive technology. It comes at its cost, but when you look at it from an operator point of view, comparing the cost of production or the cost of workover, mobilizing a rig, there is no comparison.
All right. It seems like, the ESP industry or the artificial lift industry is something that we need to really, have a broader kind of, presentations or conferences whereby people will have to exchange knowledge. We'll take it as SPE Juba section, we'll take it like to SPE International, and we'll discuss about this. We have another question here from Robert. Is asking about the market is currently looking at ESP PCP to integrate the advantages of both systems. How far is this from application in our region, and what is the success story globally?
Okay, very good question. Good question. Yeah, though I haven't mentioned ESPCP in my slides, but yes, it is one of the recently added artificial lift method to the artificial lift industry. Yes, ESPCP, which is an ESP with a PCP pump. Basically, it is the same concept of ESP. You have a sensor for data acquisition, you have a motor, you have a protector for your seal that allows you to not have burnt motor due to water or so. And then above the protector, instead of having the normal intake for the ESP, you will have an intake that is integrated with a PCP pump. You know, the axial type of pump is the axial type. So there is a mechanism, you know, whereby you need to reduce the RPM because ESP motors are rotating at very high speed, can reach up to 3,600 RPM. And then we know that PCP pumps rotate at very low speed. You can have it until maybe 45 RPM, 30 RPM application, right? So it is applicable. Globally, it is not very common. I know of ESPCPs installed in Oman for some customers in Oman and Kuwait as well. So they are working fine. I mean, in terms of statistics, I don't have exactly, but maybe globally, you know, I might need to dig into some documents to come up with some success stories about the ESPCP, or maybe Edwin, you can arrange to schedule for, because it's a topic by itself. You know, you can arrange maybe later on for any session that will cover the ESPCP, and in that we can try to gather some, you know, global statistics of how successful the ESPCP is. But I just tried to explain that it's not a very complex application. It's simply the same ESP as I explained, just with an integrated PCP pump and intake, you know. So artificial lift, there hadn't been a major change, you know, in the artificial lift business or the industry, right? Pumps had been pumped, I guess, since the 1800s. So it's a very good point. It's something in the market. A lot of customers or operators are looking into the option of ESPCP. You know, it gives them, you know, a better production than the normal ESP, than the normal PCP. And it's a wide topic. So to have exact statistics of how successful the implementation, the how they call it mean time, mean failures, and all that, as far as the ESPCP is concerned, I guess we might need to have a deep information or a session that we will go into the details and try to gather these statistics globally and see whether in the region around South Sudan it has been implemented. But I know of implementation in Oman. I know of implementation in Kuwait for the ESPCP. But looking generally into the reserve and all that, there is no any specific, I mean, use that it cannot be applicable. It cannot be applicable in a certain region, right? It can be, yeah.
All right.
But it's a very good point. I agree. Yeah.
All right, that's great. We have two more questions on the chat box. I will skip the current one because I will leave it for the final, whereby we'll hear as well your input on this, as well as we can ask maybe Gilles to add his input into it as well. So the current question is to you, Alan. This is with regard to the ESP. This is from Dominic. Dominic was saying that all this, discussion was regard to the ESP. How about the method of the artificial lift, the other methods of artificial lift, since most of the ESPs are on rental basis? He means like, how about like for sucker rods and the PCPs?
Again, I mean, the question is what?
Dominic, you can unmute yourself and direct the question directly. I think so, at least it could be more clear.
Yeah, sorry, I couldn't get it. Yeah, no problem.
Yeah. Dominic, can you hear us?
Yeah, thank you, Alan, for this well-informed Yeah, my backyard office in South Sudan. You have talked from an industry point of view. It is okay when you talk about ESPC and the technicality over these pumps. But my question that I was really wanted to ask, because you were talking about the ESPs and especially the advantages of the dual ESP as compared to the other ones. But part of your presentation really talked much about the ESP per se, but when you look at the PCPs and the Saccharot, what I was wanting to know from you is also the advantages and as to the to our fields, because if you looked into our fields, most of our fields are having high water cuts, and that is a fact of life. And ESP vis-a-vis an earlier breakthrough, and you are right to say that operators will want to recover their money, and therefore they will want to produce as possible within the times of their EPSA. Because I was in the ministry, and therefore I looked at this thing from a regulatory point of view, where you see that in as much as companies wanted to recover their investment cost, that must not also come at the expenses of our reservoir. And in countries like in the UK, I went to a number of the fields in China, and most of these guys are using Saccharot. And that has been a debate that we have talked about this with the operating companies like 10 years down the line. And I agree with Edwin that further studies must really be done into these things. But what I wanted to talk to you when you were talking about SP, I wanted you to also to lament a little bit on the PCP and the Saccharot, so that at least at the end of the day, we can as well make an informed decisions as to producing oil, but not damaging our reservoirs, because this is some of the things that you have spoken about. So this was.
Thank you, Engineer Dominic. Yeah, I got your point, and yeah, I mean it's a very valid point. The presentation I was asked just to prepare and concentrate on the ESPs and other aspects that are related to the ESP industry, right? But what you have mentioned is correct. Looking into a person who is working in ministry, you want to see what is best for the reservoirs, what is best for the future generation of the country and all that. I understand the point you're coming from. And all I can say is, because we will not be able to cover this here, but maybe what I can suggest, if it is me or if it is any other person with the experience in the artificial lift industry, is that maybe, Edwin, this is something you can note down, is I will suggest to have another presentation that is headed as, different artificial lift types or applications to the South Sudan industry, or what is the best artificial lift methods to the South Sudan oil and gas industry, right? So in that presentation, we might be able to look, because if I explain now, we know what a PCP is, what are the limitation for the depth it uses, what are the advantages of the PCP over the other one. Gas lift, we know gas lift are a mechanism, but it comes at its own cost, because the cost of the gas is high. You need to neutralize the gas when they come to the surface and all that, right? So this is also comes at its cost. So what I can suggest is, even if I explain now, I will be explaining the technicalities of what a PCP, what are the other artificial lift method is. But understanding what you have mentioned is that it's important that we have another presentation with anyone who is in the field, or to come and compare all artificial lift methods. And then, like, for example, PCP, ESPCP, ESP, normal ESP, and then how good are they to the South Sudan industry from different perspectives, from production, from reservoir management point of view. And in that presentation, we will have the details, and it will give you a broad information that, okay, our reservoirs in South Sudan, we need to go mostly for this type of application. over the other one to manage the reservoir, and then it will go to other details, right? But at the
Hello? Alan, can you hear us? All right, Dominic, just while waiting for Alan to come back, we are working with the MOP actually on this. We are looking forward to host a kind of international forum by next year, whereby all this kind of artificial lift technology will be discussed. All right, so we are doing our best as SPE Juba Section to make sure that the technical information is disseminated properly, and is for like a win-win situation whereby the country will be benefiting as well. All right, so this is just for information. All right.
No, thank you. I was just this is very good. Sorry, the rest of the colleagues who are here. I no longer work in the ministry, but again, this country, we used to. I mean, we are still very much concerned because I've been part of this industry for quite a long time. But that is the objectives of such kind of technical, expertise meetings, because we need to really, help in giving out there, an informed decision.
Sure.
Because most of our industries are being run by politicians, and that is a tragedy of our industry. And so, the little expertise that you people are having here and there may really help. Because we are looking another couple of years, what will be the industry in South Sudan like?
Sorry, guys. Yeah, I just got disconnected. Sorry.
Yeah, sure. So, Alan, I think the question was, properly answered by yourself, and I just add some comments to Dominic. And actually, we are looking forward for like more engagements in the near future at the higher level for artificial lift technology, not just focusing on ESP only. All right. So, I think Dominic, you're satisfied with this answer, right?
No, I'm totally satisfied. I mean, with what the engineer has just given to me.
Okay, that's good. We have last question on the chat box, unless maybe someone else is going to raise another question through by unmuting themselves. We have a question here, Alan, and this question actually, you are the one going to answer it, and then Mr. Gills is here as well. He can add more because it's more technical question from a technical person. So it's asking about, this is a question from David. David is a wireline field engineer working on interventions. So it's a question about, will the ESP still be same as effective with the tailpipe installed below for deeper intervention compared to when they are without installing it and below the Y tool?
Yes. So yeah, it's a very good question. I will have my input, and then if Gilles would like to add some, he will be welcome. Yeah. So as I explained earlier, the application of the ESP in regards to the tailpipe. So the tailpipe doesn't have any direct or indirect effect on the ESP, with exception of the issue of the load. As I explained earlier when I shared the screen, there was this pump support part that is right at the bottom of the sensor, at the bottom of the Y tool system, right? So while I was explaining the function of the pump support block, I said the pump support block, its main and only reason is to have the weight of the tailpipe that is below the ESP. And I've given examples where we might have a very long tailpipe where the client or the operator would like to have interventions. And instead of having this weight on the ESP, which we know very well that the ESP is designed, the balls on the ESP are not designed for such a very high tensile strength, because when we talk of 1,000 feet or 1,500 to 2,000 feet of tailpipe, that is, we are talking of a very high weight in terms of pounds or in terms of kilograms that will be impacting either on the ESP or on the Y tool above. That's why ESP companies came up with the plan of having pump support blocks that can only withstand the weight of the tailpipe that is below the ESP. But it is not having any direct or indirect impact on the ESP performance, because the ESP is above the tailpipe, and the weight is not shared by any means or by any way that it's shared by the ESP string or the ESP component. So there is no any direct or indirect effect of the tailpipe on the ESP system, to answer that question. So I don't know if Gilles have something to add also, is welcome.
Thank you, Alan. Gilles, are you on the line? I think you are muted. If you have any additional to this question, maybe you can add your input.
Hello, good afternoon. Thank you, Alan. That was a good presentation. I think what Alan have said is quite enough. Yes, we can use the tailpipe up to a certain depth, and everything will be based on the design. We can go. We have the deepest up to 15,000 in Canada. We have some examples that were not presented during the speech. However, the only restriction would be on the boat used on the ESPs. Okay, if you install your tailpipe directly on the ESP without the white tool, which is also possible, we call that inverted ESP or a different set of ESP when we have the perforation below, perforated tube below the ESP, then the depth will depend on how heavy can the ESP withstand. Okay, so how much can we apply on the bolt pattern? Because ESP is a set of equipment that is actually bolted, not tied, not threaded. And once we have this calculation, then determine how deep we can install, how many tubings can be installed below the ESP. That is when it's connected on the ESP. Now, when it's connected on a bypass tubing, it's very simple. The weight is not only on the not even on the tubing, on the ESP. Sorry. So you can install as many as you can based on how much tensile do you put on white tool. That's the maximum. The maximum will depend on your white tool. So if you have a bigger white tool, which is 10, maybe 13 inches, then you can install as much as you can. So there's no restriction actually. The pump will operate if there is no restriction on the motor and on the pump itself. When I say ESP will operate if there's no restriction on the pump or the motor. So if you don't impact the motor, there's no problem. If you don't impact the pump, there's no problem. As long as you have all your design well reviewed and approved by all the participants. I hope that answers your question, Robert or Dominic.
Okay, so thank you, Gilles, for stepping in and share your experience as well. If there are no more questions on the chat box, and if there was any question to be addressed from anyone, I would like to thank you, Alan, for this opportunity. Actually, we can call it a short notes. However, you managed to step in and share your experience with SPE Juba section. And we are looking for more, forward for more engagement with you as an expert on this field. And I would like to take this, opportunity to just remind our members that we are approaching the end of the year. So if you are a member and your membership is about to expire by 31st of December, please do go ahead and renew it. If you are not yet a member, please join the SPE through the website and become a member. We have more programs to come in the upcoming year, and we would like you to join us on those programs. So, Alan, do you have anything to share before we move into the next, the next stage whereby we have an announcement before we end the meeting? We have an announcement, yeah.
No, not much. All I can say is I just thank you, Edwin, and SPE Juba Section once more for extending the invite. And yeah, it had been a pleasure trying to share my humble experience in the industry, more specifically about the artificial lift. And yeah, it's always a pleasure to try to share this, and available. Yeah, should you guys require like further engagements on different topics related to the artificial lift industry, I will be happy to step in and support, yeah, with the humble experience that I have. But again, saying, it had been an absolute pleasure for me to be with you and sharing these slides and getting these valuable questions and inputs from each and everyone, right? I just hope that I was successful enough in the way I presented the slide and in the way that I tackled your answers. Yeah, so thank you once more for having me.
Okay, thank you so much, Alan, for this. For the next stage, I think Benedict will be sharing his screen. He just want to make few announcements before we end the session. So Benedict, please go ahead. You are the host at the moment. Benedict, can you hear us? Hello, Benedict. All right, Benedict, you are host. So please share your screen. I think we just left with 15 minutes before we end the session. So Alan, I have a question here while Benedict is like preparing himself, huh? So
yeah, no problem. Yeah.
Yes, you mentioned about the dual ESP on the applications on offshore, whereby you use once you run single ESP, and then you make the other one as the backup, unless if there is a failure, it will work. So just a question here: how suitable is the dual ESP in our commingled production environment in case of like other application rather than the dump flat application? Is there any kind of other application that this dual ESP can suit into with our brownfields and deplete reservoirs and such kind of things?
Yeah, see, yeah, trying to answer your question. Yeah, see, having the ESP as a backup, having the second ESP as a backup is just one of the uses of this dual ESP, right? But I think I've mentioned also something about production from different zones using these two ESPs, because where you are going to set the two ESPs can be in two different reservoirs, can be in the same reservoir. In two different reservoirs, you're going to have isolation packers in between them. So each ESP is going to function independently, separately from the other. The zones will be totally isolated. So in regards to the South Sudan fields, right, where you have like this commingled production or reservoirs, you can totally isolate them with isolation packers, and then have production from two different formations, or can be from same formation but isolated ones. So once, according to your study, once it is selected to be produced from a certain formation, so once you run the isolation packers between them, So the two ESPs will not have any interconnection between each other. The two reservoirs will not have any connection between the two. And you will have a total isolation in between them, and you can use the dual ESP. So dual ESP can be used, and if I'm not mistaken, there is an application of a dual ESP system. It was dated back in 2011, 2010, I guess, in Higlik area, where dual ESP was run there, and it was successful. It was a success story. I remember very well the dual ESP. So in our reservoirs, in our formations, looking into the characteristics of the reservoirs, the dual ESPs are applicable, and it can be used. Yeah.
Okay, that's great. That's great. Okay, this is just an addition. I'm just asking. I'm taking it from the perspective of an operator. Let's say I'm an operator, and I'm looking at the cost-benefit analysis. The single ESP versus the dual ESP. What can I benefit from the dual ESP in the long run compared to the single ESP, whereby I have issues and I keep bringing the walkover rigs to pull out the ESP and then install a new ESP? I mean, I'm looking at it from the cost-benefit analysis. Can you just elaborate on that?
Yes. Yeah. So what I can share here is, like, for you being an operator, or as from an operator point of view, right? A dual ESP for you will mean what? Dual ESP for you as an operator will mean two sets of ESP, be it is rental, it is a direct sale, you're buying them. Anyway, it's the cost of two ESP strings, okay? Two ESP strings that sooner or later you can exhaust them in this well or in the next well. For you, it's the cost of two ESP. However, it is for you a cost of one rig intervention that you will use only to install these two ESPs and then run the tubing, do the surface setup once and for all. So for you, beside having the cost of the two ESPs, everything else is going to be the cost of one rig mobilization. So whenever you install this rig, you install these ESPs with the dual system, and then each ESP, for example, gives you a run life of 2 to 3 years. So you will have 4 or 6 years of production without rig intervention, which is for you as an operator. You know, I think being an operator, you know very well the cost of the rig and the mobilizations and all that more than the ESP providers, right? So it is not a comparing equation. You cannot compare the cost of frequent rig interventions and mobilizations, looking into the difficulty of the environment there and how suitable the rigs can move from one location to the other. And then you pull out, because when you pull out, you're adding the cost of the rig crew, you're adding the cost of the tubing, you're going to change the tubing, you're going to have other interventions as well. However, when you have a dual ESP, the cost is only once, and then you have a two ESP in the system. You will have to bear the cost of the two ESPs that will be installed. But in the long run, looking into the finances of both systems, it will clearly tell you that the ESP system is cost saving for you as an operator, more than having frequent interventions where you need to mobilize rig and pull and run new completions. Yeah.
Okay.
I'll try to answer your question.
That was really have answered my question. It's just what I was about to refer to is that it's now the operator and the regulatory bodies exercise to be able to do the cost benefit analysis, because at the end of the day they are the stakeholders. And this one actually will take it into another forums whereby it will discuss in detail, and it have to be a win-win situation for all the parties involved from such kind of industry. With that one, I'm seeing Benedict having some difficulty on sharing the screen. However, he will communicate the message to all the teams through our SPE Inform system, as well as the WhatsApp group. And with that one, we come to the end of the session. I would like to thank you so much, Alan, for being patient on the 2 hours with us. And we are looking for contribution of more people who will be presenting in the near future. We have 4 presenters will be presenting on the same program who are 10 plus years experience in oil and gas industry. So, okay, Benedict is able to share now. Benedict? Okay. So, Benedict, are you able to hear us? I think we just left a few minutes. Yes, Benedict, go ahead. I think Benedict is having some issues with the mic. Benedict, we cannot hear you. Okay. Okay, so I think Benedict is trying to, pass the message of our upcoming distinguished lecture program, which will happen. There are 2 distinguished lecturer program. One will happen on Wednesday, 27th of January. This is for a distinguished lecturer called Philip Hart, and it will be about techniques to reduce operating costs for increased reserve and profitability, right? And then the second one will be from Raymond Tipples, and it will be about getting the most from your open hole gravel packs. This is for completion, and it will happen on 18th of March 2021. Okay. So Benedict, you move to the next slide at least. Yeah. Benedict, are you still able to communicate, or your mic is not? He's not able to. I think Benedict is not able to. So for the same program, we have upcoming presenters on like Q1 2021. We have a guest speaker from Saudi Aramco. It's called Osman Hamid. Is someone with more than 15 years in geomechanics, especially in drilling. We have another guest speaker who is well known to us, Mr. Roman Germeleli. He is currently a senior production engineer with Apache Corporation, the American company in Egypt, and he will be presenting on production and operation discipline. We have another guest speakers. We have Mr. Saleh Nuruddin, who is currently like a well placement engineer, or we can call it a drilling engineer, working in Kuwait. He have more than 15 years experience on drilling. And we have Mr. A.K. Joshi, who is based in India, and he worked for a long time with OVL or ONGC for more than 20 to 30 years. And then he's currently as the director of one of the SPE sections in India. And he will be presenting on HSE and sustainability discipline. So I'm just like giving you what Benedict have presented. So stay in touch and keep watching our, our LinkedIn page, as well as our WhatsApp group for more programs to come. And we would like you as well to follow our YouTube channel, whereby this session is recorded and it will be broadcasted, or it will be uploaded to our YouTube channel. And with that one, I would like to thank everyone, and we are looking forward to see you in the near future. All right, thank you, everyone.
Thank you.